Welcome in this afternoon talk about distributed parallel computing with JavaScript. That's going to be specifically based on so-called Golem network. And a quick question to you guys. How many of you did hear about the Golem network at all? Hands up. OK, there's a couple of hands in here, but not a lot. And this is the thing which I wanted to change, really. My name is Grzegorz Godlewski. The nickname Grisha sticked with me somewhere in the junior high. Right now, I'm working as a technical lead for the JavaScript/TypeScript SDK team at Golem Factory. So I have the privilege to do one of the most rarest things, probably. So I'm building up actual SDKs for developers. And the goal for our team pretty much is to build up a set of tools which is going to help to interact and run applications on top of Golem network. What the Golem network is on its own, I'm going to explain in a moment. But just to give you a little bit more of a context, we're operating in a problem space of CPU-demanding operations, which require a lot of time to complete. And most of the time, you can say about them that these should be like isolated computations. So you have like an input, you convert to an output, and you don't have any dependencies pretty much about the tasks. So some of the examples include mathematical calculations, video, audio, image, or text processing. So essentially, most of the time, CPU-bound stuff. And just for the purpose of the presentation, I'm just going to give you an example. So that's JavaScript piece of code, which is calculating the nth element of a Fibonacci series, classical implementation. On my machine, for a number of n around 45, this is starting to be like super, super slow. It takes a number of minutes really to compute. So obviously, we do know that JavaScript is not a proper mathematical language, but I just needed to have an example to depict a long-running operation, which is good for a presentation. Now, if you were to get a set of data points, like you have the input data set of size of like 10, 50, 100, and you go over 1,000, the simple implementation, which most of us probably would go for the very beginning, would be very, very slow. So you can go via standard loop. You can loop over the array, calculate the value, put them all out. If you try to be smart, you can try to map it and try to run concurrent processing over here. But trust me, I've did some CPU comparisons and some benchmarks on this. There's little difference. And the reason for that is that, as you probably heard, JavaScript in Node.js is single-threaded, although Node.js is multi-threaded, and V8 is essentially multi-threaded. We are bound to a single CPU thread, pretty much. But we're not really super limited, because there are other ways how we can deal with super big data sets. And some of you may eventually heard about a library called Threads. So that's a library which allows you to run workers either on browser or on Node.js. And what essentially you're doing here is that you're spawning a pool of workers which are going to calculate the values for you. So in my case, I'm having a 12-core machine over here. So I'm going to have 12 additional threads. And then the whole data set which I got there, I'm going to map over and queue computations for each and every value towards that pool. And then classical, await, promise all with tasks, and then I'm going to get all the calculations out. This is way much faster than the previous implementations because it's utilizing all the threads and cores which I'm having on my system, not a single one. We had the pizza situation a moment ago during the lunchtime, so you can imagine what's the difference, right? So if we had more of those tables with the pizzas, probably we would get along with that pretty much faster. But yeah, that's how it goes. Now, when it comes to the details of that implementation of that worker, the threads library puts out a very nice expose function. So in the worker itself, I'm just going to expose an object which supports compute. And internally, it's using that Fibonacci function. So pretty much a simple wrapper for my logic, which I can then use in a multi-threaded manner. And with this said, we've kind of reached the situation that we've used all of the 12 threads which I had on my machine, but I'm still bound to a single processor. So if I were to span those computations even wider, then I would have to go for a multiprocessor architectures, which includes things like classical things like microservice over like Kubernetes cluster, load balancer. You shoot out all of those requests, you collect the responses back, and you build up the final array. Or you can go for a worker, which is going to be deployed in many replicas again, and a queuing system, and then you go for some messaging-based RPCs, right? So you send a message, please calculate this, and you get a message back in response. Now, it's not that you have this way or the other way. Today I wanted to show you the different way, which is exactly based on Golem network. And this is the place where we're going to talk about the Golem network just a little bit. So essentially, the long description states that the Golem democratizes society's access to computing power by creating a decentralized platform where anyone can build a variety of applications, request computational resources, and or offer their idle systems in exchange for a cryptocurrency token. This is like super verbose, sounds complicated, but let me put this in a simple term. I'm having my laptop and I'm not using it all the time in 100%. So what I can do in this scenario is that I can become a so-called provider on the network. So the very guy at the very top on the provider section is going to be me putting my laptop into the network, and so does many other people on the network. So they are having like personal hardware, they're having data center machines like bare metal machines connected to the network, and those machines expose their computing resources on an open market. On the other hand, we have different types of users. So let's say a friend of mine, Arthur, is going to issue some computation requests, like the example here, which I gave you on the presentation. But he doesn't want to buy all the infrastructure from AWS, Google, whatever. He doesn't want to pay for all of those invoices, put credit cards anywhere, stuff like that. So what you can do instead, you can join the network as a requester and then run your computations on the network using the hardware exposed by the providers. And the thing is that if I'm a provider on the network and I'm renting my resources, I'm gathering GLMs. So that's like a token. Treat this as a virtual currency, pretty much. So you're collecting some virtual currency, some sort of like a coin, which then later on, in turn, you, as a provider, can use as one of the users. So I'm just going to rent out my computing power, and then a month or two later, I'm just going to get it back by paying with those GLMs which I've got previously. So here I wanted to show you how an example implementation of this kind of computations looks using the SDK which we're building. Well, we have the task executor. This time, a moment ago, we saw a task runner, so definitely a naming challenge over here. And that code is super simplified. What goes on here is the following. At the very beginning, we need to prepare some configuration for the market, because that's a market. So the providers on the previous page, they are having their own pricing for start time, CPU time, environment time, stuff like that. So if I'm joining as a requester, I need to specify some configuration, how I would like to interact with the market. Then I'm building up an instance of the executor with this, and then you saw the rest. I'm getting the input, and I'm going to compute the values on top of Golem, show the results, and then clean up the resources. Now, how does the make config function look inside? I'm not going to go into the details. This is the docs where we are exposing the details, but pretty much this determines your pricing strategy, like how much you are willing to pay for those computations. Also, what you would like to also do is to use a whitelist of providers, because if anybody can join such a network, you can have different types of quality of the providers on the network. Some of them are very good, some of them are very bad. So what would you like to do is to get a list of pre-tested providers, which give you a very high chance for success with computations, and we got you covered. Essentially, I've built that endpoint just yesterday, which is benchmarking the providers on the network. We have 350 providers plus on the network right now. So I've chosen the ones which are working, and then you can utilize this in order to get your computations done. When it comes to the computations on their own, this is a little bit more difficult than in the previous examples, because what I did here essentially is that for each and every input, well, not for each and every input, but for each and every provider whom I'm interacting with, I'm uploading my own script file. So that's pretty much another version of that Fibonacci script file. I'm uploading this file to a remote machine. So if Artur is requesting work and my computer is going to serve that, Artur's PC is going to upload the script on my end, and then you can see what's going on next. I'm running Node on that remote server, so essentially on my machine, and it's computing the task with the provided input, right? So for each and every input, there's the map, and then for each and every input over there, a command is being run. And then we return the tasks as a result, await, and we get the results. And so what you can see here on this screenshot is me running a test for 1,000 of inputs. And here you can see how that distributed between different providers. So on the third column, actually, you see the provider names, so the computers which were serving the requests, how many tasks they had, how many GLMs they did earn, and at the very bottom, you can see what's the total cost and the computing time. So 329 seconds, 1,000 values across 12 machines on the network. So this is pretty much this. And then I went for another type of implementation. So if you recall what I've said previously, Node.js is running on a single thread, like JavaScript is being executed on a single thread. So I combined things. What I did next is that I took that threads-based implementation, you recall that one, right, with the pool of workers, and I've created a custom image. And this is the thing which I'm deploying to the providers right now. So essentially, the script which is going inside is supporting multi-threading. So when my code is executed on that provider, I'm utilizing all of the cores which that provider offers. Previously, I didn't. Right now, I do. So in order to utilize this at best, I'm doing one additional thing. I'm not putting out the inputs one by one as previously, but I'm chunking this. So for the amount of data which I had, I'm creating chunks of 100 elements of length, and then I'm computing chunks on top of Golem. So how does this look now in operation? Similar to the previous one, so I still need to upload something to the provider. So I'm uploading a chunked data set, which I'm writing into a file just a line above, right? And then what goes next, there's, again, Node being executed on the other end, and it's really loading that data set, so those 100 values, and computing that. Now, how does this look on the output? Now you can see that if I had like 1,000 of entries chunked by 100, I essentially created 10 chunks. So I involved 10 providers on the network, not producing 1,000 tasks, but 10, but all of those tasks were running multi-threaded on each and every provider. What happened, if you paid attention, we've cut down the time for computation by a half. So that was 370 previously, 120 right now, and the cost also went down from 0.09 something GLM to 0.036. So this proves to be more efficient. So I'm issuing less work on the network, and I'm utilizing the machines better by using multi-threading. And yeah, I would like to invite you to join the network as creators, essentially, because as a person who is building up the SDK together with my friends at the company, we are looking forward to have new JavaScript developers using the network. So we're building up the SDK. Make sure that you've check it out. If you have some concerns, you have some questions, you can find me, by the t-shirt, that's one thing. I'll be just lurking around. And I also prepare small giveaways which will allow the interested people to get started working on the network. So just please approach me and I will let you know about the details. You need to bear in mind that currently there are some limitations on the network, just for being transparent. So if you're on a provider, you cannot access the internet easily. This is possible, but you cannot do it easily. That's to protect the providers. And also, the network supports a VPN scenario, so you can spin up, like, if I've involved 10 providers, I can make them talk to one another within a VPN. The network supports that, but we're building the support in the SDK at the moment. And what I've mentioned previously, there's a varying quality of providers when it comes to health and operation, and we got you covered by that whitelisting solution. And since React is pretty much a theme today, I need to mention that we are also building React hooks for front-end development, because you can run that code also on a browser. So the SDK is usable on front-end, so your front-end can interact with a network, essentially. And we didn't have a coverage for React. Now we're going to have it in just a couple of weeks. You can find this presentation, examples, working examples under this QR code. There are also examples from the meet.js meetup from a month ago. So make sure you check it out. And yeah, in case you would like to connect, that's the way.
Okay, thank you. This is super interesting. And there's so many questions, but all of them are about security.
Oh, so, yeah, definitely.
How am I protected from someone else's code doing bad stuff when I'm a provider?
Yeah, so essentially that's the reason why you don't have easy internet access. So it's not easy to create a botnet, and right now impossible to create a web scraper, which is going to rip off the half of the internet. The access to the internet is super limited. So there's a list of whitelisted addresses which you can utilize. But if you would like to access additional ones, there are two ways of how we can do it. There's a certification way. So your application manifest is getting signed by a certificate which Golem approves, and then we're using a trust chain. And a new feature which comes in is a partner rule, which can pretty much mean that providers on the right-hand side then can partner up with certain requesters, and then those providers, that's an open market, then providers can enable that particular requester for internet access if they agree to and under certain terms. So this is non-technical, pretty much has to be agreed between parties.
Yeah, that's a good way to bootstrap it, and I know who I'm going to spend a lot of time talking to at the after party. So thanks again to Grzegorz.
Thank you very much.